This video is about solving problems using sine, cosine, and tangent ratios. In this video, we are looking at some situations that we can use sine, cosine, and tangent ratios and answering questions about side lengths using those ratios. Let's get started. Let's start with lesson 28 about solving problems using sine and cosine on page 182 of your student materials. In this first problem, the bus drops you off at the corner of 8th Street and 1st Street, which I think is right here, approximately 300 feet from school. So this length right here is 300 feet. You plan to walk to your friend Janet's house after school to work on a project. So you're walking from school to your friend's house after school. Approximately how many feet will you have to walk from school to Janet's house? So this is going to be x. And we're given this angle is 41 degrees. So the reason why we're using sine or cosine is because we have an angle. If we didn't have an angle, we just had two side lengths, we would then use the Pythagorean theorem. So I know this is 300, and I want to find this length right here. I will start by labeling the side that I know and the side that I want to know as adjacent as the leg adjacent to the angle, the leg opposite the angle, or the hypotenuse of the triangle. So this is the leg that's on the opposite side from the angle. This is the opposite. And x is the hypotenuse. So our mnemonic is SOHCAHTOA. And I want the ratio that relates the opposite and the hypotenuse, which is the sine ratio. And I know the sine of the angle, 41 degrees, is equal to the opposite, which is 300, divided by the hypotenuse, which is x. And the sine ratio for 41 degrees is 0.656, which is equal to 300 over x. Put this divided by 1, and then I cross multiply. And I get 300 is equal to 0.656x. And then I get rid of the 0.0656 by doing the opposite of multiplying by x. I divide 0.656. And x is equal to 457 feet would be the answer. Okay, let's look at another problem in this lesson. Number 5, a shipmate set a boat to sail exactly 27 degrees northeast from the dock. After traveling 120 miles, the shipmate realized that he had misunderstood the instructions from the captain. He was supposed to set the sail going directly east. That's a pretty big mistake after going 120 miles. Down here we're asked how many miles will the shipmate have to travel directly south before he is directly east of the dock? So I need to figure out what this length is right here. And I know this is 27 degrees. And again, I used sine, cosine, or tangent because I know an angle and I know one side length. So the first step is you label the side that you know and the side that you want to know. This is the hypotenuse. It's the longest side, and it's across from the right angle. And x is the opposite. And so my mnemonic, SOHCAHTOA, make sure you memorize that and how to spell it. And again, the hypotenuse and the opposite is the sine ratio again. So the sine of 27 degrees is the opposite over the hypotenuse. This is x over 120. And the sine of 27 degrees is 0.454, which is equal to x over 120. Put this over 1 so it looks like a proportion. 1 times x is x, and 120 times 0.454 is 54 miles, rounding it to the nearest mile. B asks, how many extra miles does the shipmate travel by going the wrong direction compared to going directly east? So I'm asked to find this length down here, y. Now I could use 54, this length right here, but That was a rounded off answer. I was given this as exactly 120. And so I'm going to still use the hypotenuse. And just to be super clear, I'm going to kind of forget about that for a second and focus on the hypotenuse and y, which is the adjacent. And this is now the cosine ratio. And although I would ask you to write this down here below B, I want to see the diagram, so I'll put it over on this side. So I know that the cosine of the same angle, 27 degrees, is equal to the adjacent, which is y, or I'm calling it y, divided by the hypotenuse, which is 120. The cosine of 27 degrees is 0.891, which is equal to y over 120. I then make it look like a proportion, and I cross multiply, and y is equal to 0.891 times 120, which is well, this is the answer, and it's right to the nearest mile. And so it's 107 miles. So this length down here is 107 miles. Now, I've been asked to, the question is, how many extra miles does the shipmate travel by going the wrong direction? So this length, again, is the 54 miles. And so as the shipmate went 120 and then 54 miles, if I add 120 and 54, I find that the shipmate actually went 174 miles. But if I subtract the difference between that distance and the 107, then I find that the difference is 67 miles. So the shipmate accidentally traveled 67 more miles by making that mistake. The last question we'll do will be with lesson 29 about applying tangents, and we'll do example 1. So Scott, whose eye level is 1.5 meters above the ground, so here's Scott's eye, and this distance is 1.5 meters. Stands 30 meters from a tree. This is not to scale because this is supposed to be 30 meters, and I doubt Scott is, that tall. Anyway, so it's 30 meters above the ground, and the angle of elevation, meaning from horizontal looking up at a bird at the top of the tree, that this angle of elevation going from horizontal up is 36 degrees. How far above the ground is the bird? Well, I need to find a right triangle so that I can answer this question. If I think about the distance from the bird down to the tree and looking at the height as perpendicular to the ground, then I have this right triangle right here. And I want to know this length right here, how high the bird is from Scott's eye level. Okay, and we'll deal with this 1.5 meters towards the end of the problem. Okay, the first thing you do is you label the side that you know and the side that you want to know from the angle. Now 30 meters is the leg that's adjacent to the angle. X is the leg that's on the opposite side from the angle. And SOHCAHTOA, the ratio I need to use is the tangent ratio. And the tangent of 36 degrees is the opposite, which is x, divided by the adjacent, which is 30. And the tangent of 36 degrees is 0.727, which is equal to x over 30, divide by 1, and cross multiply. And I find that x is equal to 15.85 meters. Now, that isn't the answer, but that's the distance from Scott's eye level up to the bird. It's 15.85 meters, and it tells me to, it doesn't tell me how precise I need to be. And I know that from the eye level down is 1.5 meters. So if I add those together, I find that the bird, if I add these together, the bird is about 17.35 meters above ground. Okay, so there'll be more situations to look at, but that's at least to get you started on how to use sine, cosine, and tangent in applied problems to answer questions about side lengths. So this video is about solving problems using sine, cosine, and tangent ratios. Thank you for watching.